Hello friends, today we are going to solve a very important exercise 5.2. Okay, in the previous lecture we had already learned about modulus and polar form of the complex number. Now today also our questions are related to this. Find modulus and argument. Actually principal argument is the word. So find modulus and argument of following complex number. Of following complex numbers. This is the instruction. Let us start with the very first question. See here, every complex number says z. So first complex number is z is equals to -1 minus I root 3. See here, -1 minus I root 3. So we start with the modulus. Okay, here modulus z. Okay, here z represents a point. First of all, z represents point. Which point represents z? पहला point find out कर लेगा. See here, this is a plus ib. So a is -1 and b is minus root 3. See here, this point representing by this complex number which is in third quadrant. Which is in third quadrant, right? So this point is in third quadrant. So now modulus z. What is modulus z? Under root a square plus b square. So under root a square. So -1 square plus minus root 3 square, right? And what is this? I think you know easily. That is 1 plus 3, 4. And that's why square root of 4 is 2. So 2 is the modulus of the complex number. Very simple. And argument of z. Argument of z or theta, this theta or argument of z in third quadrant. You know the table. In the previous lecture we had already learned that table, and the table was that in third quadrant argument of z is minus pi plus tan inverse b by a. If you remember that, this is the argument related to complex number in third quadrant. So that is minus pi plus tan inverse b by a. B by a means, remember that root 3 by 1. Root 3 by 1. Now you know from standard 10. Root 3 value. Root 3 is the value for the complex number. For which angle? Do you know that? I think you know that root 3 is the value for the angle in third quadrant. Okay, so tan ની value root 3 ક્યારે થાય? I think તમને ખબર છે ને? The value of tan function being root 3. ચલો યાદ કરો ફટાફટ. Then I think you can easily remember that result. 60 degree યાદ છે તમને? minus pi plus 60 degree. If you do not know then, this is 60 degree is tan root 3. अच्छा, 60 degree ने radian measurement में શું લગાય ખબર તમને? That is pi by 3. Okay, I write the reason. The reason is pi is 180 degree. આ યાદ રાખજો, pi is 180 degree. So 60 degree means 180 by 3. Actually we just write in the radian measurement. So this is minus 2 pi by 3. આવડે ને LCM? minus 3 pi plus pi is minus 2 pi by 3. So minus 2 pi by 3 is the argument of this complex number. તો આ મેથડથી તમને આર્ગ્યુમેન્ટ મળી જાય, મોડ્યુલસ મળી જાય. Now the second question. Second question is this: z is equals to minus root 3 plus I once again. But the symbol or here the negative sign is this. So z represents which point? This z represents minus root 3 1. Minus plus is in first quadrant. Second quadrant. This is in second quadrant. So this complex number represent second quadrant. Now modulus z. What is modulus z? Again under root a square plus b square. So minus root 3 square plus 1 square. Again this is root 3 plus 1 my friend. That is root 4 and that is 2. So modulus z is 2. And what is argument of z? You know that in second quadrant your formula is pi minus tan inverse b by a. So pi minus tan inverse b by a. So 1 by root 3. Remember that positive, all write this as positive. Now do you know that tan inverse 1 by root 3 is what? Is actually pi by 6. It means 30 degree. I think you know that that is 30 degree. And 30 degree can be written as pi by 6. Okay, now take LCM. Avade ne LCM? 6 ones are 6 pi minus pi by 6. So that is 5 pi by 6. So that's why this complex number consists argument as 5 pi by 6 and modulus as 2. Okay. I think now you easily understand how to find out argument and modulus. Now convert this following complex number in polar form. Convert following complex number into polar form. Polar form ma conversion કરવું છે. Let me convert it. Okay, first complex number or your example number 3 actually. A complex number z is equals to 1 minus I, my friend. 1 minus I is the complex number. First of all, let me write it as a plus ib. See here. This is z equals to a plus ib, where what is a and b? I think you easily understand. Compare karta avde ne. A is the real part 1. So a is 1 and b is minus 1 here. It means 1 comma minus 1. Positive, negative. I think you know that positive, negative means in fourth quadrant. So which lies in fourth quadrant. This complex number lies in fourth quadrant. And now first of all I just find out r. It means modulus. So therefore r equals to modulus z. And therefore what is r? Is under root a square. So a square is 1 square plus again minus 1 square is also 1. So what is r? R is root 2. It means modulus is root 2. And what about argument of z? Do you know that argz in fourth quadrant? So તમારે યાદ રાખવું પડશે. In fourth quadrant is minus tan inverse. Minus sign is outside. B by a. So 1 by 1 minus tan inverse 1. And I think you know that tan inverse 1, tan ni value 1 at pi by 4, 45 degree. So that is minus 45 degree. But we have to write here radian measurement. So that is minus pi by 4. So theta is minus pi by 4. Remember that argz, argument of z is theta. And modulus z is r. R means modulus and theta means argument. Now with help of r and theta, we may easily write a complex number as a polar form. So therefore polar form. What is polar form? So polar form of complex number is z equals to, do you know the polar form? Is r in the bracket cos theta plus I sin theta. Right, this is the polar form of the complex number, and let me put the value. So therefore z is equals to root 2 into bracket. I write cos minus pi by 4 plus I sin again minus pi by 4, and this is the answer. This is actually polar form of this complex number. So this is the method, my friend, to derive it. Now the fourth question. Let me derive the fourth one. Question number 4 is this. Z is equals to minus 1 plus I. So minus 1 plus I. Again, just you write it as a plus IB. Then I can say that Z equals to minus 1 plus I into 1. Right? This represents AB as a point. So point kayo represent you. A is minus 1 and B is 1. Minus plus lies in second quadrant. See here, lies in second quadrant. Now two important things we have to find, R and theta. So now R is modulus Z, we know that. So under root, again minus 1 square is 1 plus 1. So R is root 2. Once again R is root 2. But what about argument? Then argument of Z. Do you know that in second quadrant argument is pi minus tan inverse B by A. But do not write here negative sign, right? Actually modulus hoy. So that is actually theta is pi minus. Now tan inverse 1, my friend, tan inverse 1 is pi by 4. So theta is pi minus pi by 4. Let us take LCM. Then that is 4 pi minus pi. LCM to avade na, 4 is multiplied there, minus pi by 4. So what the argument is? 3 pi by 4. So 3 pi by 4 is theta, root 2 is R, and therefore polar form of a complex number. Therefore polar form is, what is polar form? Z is equals to, I think you know that, R into bracket cos theta plus I sin theta. So therefore this Z is equals to, R means again root 2 into bracket cos 3 pi by 4 plus I sin 3 pi by 4. Right? This is polar form of the complex number. Now see my friend, what the change here? The change is about this argument, it means angle. This angle change, then the form of the complex number is changed. See here the angle is what? Minus pi by 4, because this complex number was in fourth quadrant, that's why angle is negative. This complex number was in second quadrant, that's why angle is positive. It means all the thing is about quadrant. Quadrant plays here important role. Okay, so my dear friend, you just solve yourself one more example, fifth one. That is Z equals to minus 1 minus I. You have to solve in homework, right? I think you can easily solve it. Again, A plus IB, just compare this with A plus IB. Then A is minus 1, B is also minus 1. And with help of that, you may find easily modulus and that after argument. And with help of that, we may write polar form of the complex number. Okay. So here we stop now. In the next lecture, we will deal with another example. Thank you very much.